One of the most often used areas of coordinate geometry is straight line equations. Let's look at how we generate these then. So I need to first of all know a point that's on my line. So here's a known point x1, y1. I can pick any other coordinate on this line, and I know that the gradient between these 2 points is always going to be the same thing. Commonly it's denoted as m. This is potentially for the French meaning mountain or to climb. I think it's something like mont. Anyway, we pick a generic point which we're going to call x, y. We find the change in y, which is going to be y minus y1, and we find the change in x, which is going to be x minus x1. And we know that when we find the gradient there, y minus y1 divided by x minus x1, we're always going to get the same value. We're always going to get this value m, this constant gradient. Now I can rearrange this slightly to give me y minus y1 is equal to m lots of x minus x1, and this is the most common format of finding the equation for a straight line, where we know the gradient and we know a point on that line, and then we can use that equation every single time to get us the equation of a straight line. Let's look at that in action then. So very simply here we've got an equation for a line with gradient 4 that passes through the point to -2, 3. So using my equation, y minus y1 is equal to m lots of x minus x1 would give me y minus 3 is equal to 4 lots of x minus minus 2, which is y minus 3 is equal to 4x plus 8, or y is equal to 4x plus 11. And there's the equation of my line that will have gradient 4 and will go through the point -2, 3. In my next example, I'm looking for an equation of a line that passes through 2 given points. Now if I've been given 2 points, I can find the gradient between them. To do that, I take either one of the points as my initial, so let's use the latter, which is going to be then -6, take the change in y, so -6 take away 3, over the change in x, which is going to be 2 take away -1. And if I do that, -6 take away 3 is -9, divided by 3, which tells me here that the gradient is going to be -3. So again, using the one and only equation that we will only ever use to find the equation of a straight line, I've got the gradient is -3, and this is what the equation should look like. Now I could choose either one of these points and I would end up with the same equation. So if I pick the first point, I would be doing y minus 3 is equal to -3 lots of x minus -1, which is y minus 3 is equal to -3x minus 3, which would give me y is equal to -3x. Then just in case you didn't believe me, if we were to do it with the second point, we would have y minus 6 is equal to -3 lots of x minus 2, which would give me y plus 6 is equal to -3x plus 6, and again subtracting here we would find out that y was equal to -3x. In my final example, we've got a line that meets the x-axis at a point P. Well, if I'm told about the x-axis, this is code for y is equal to 0. Find the equation of line with this gradient. Okay, so I've got a gradient, I just need a point on the line. Oh, well that's the point P. How do I find that point P? Well, I need to solve the equation 0 is equal to 2x plus 8. So -8 is equal to 2x, so -4 is equal to x. So then I've got a coordinate which is going to be -4, 0. We've got the gradient, we know it passes through the point P, and we want to write our answer in a slightly different format. Well, there's only one way I make equations for straight lines, and that's using the equation y minus y1 is m lots of x minus x1. So now I just substitute in the information that I have. That's going to be y minus 0 is equal to 2/5 of x minus -4. I'll multiply through by 5 to give 5y is equal to 2 lots of x plus 4. and that's going to give me 5y is equal to 2x plus 8. Now I need to put it into the format that we've got here, so I'm either writing this down as 0 is equal to 2x minus 5y plus 8. The other way of doing it would be to say that minus 2x plus 5y minus 8 is equal to 0. Both of these are the same answer, they both give the same equation, and they would both be fully accepted in your exam. The most important part that we've talked about is this equation here, which is the one and only equation that you will use with straight lines for generating their equations. We have the gradient, we have a point on that line, and that gives us everything we need.